Okay, good afternoon to all of you. Today we are going to learn the homogeneous equations. If we have a differential equation, dy dx equal to fxy, however the fxy is not in the product form of function of x and function of y, mean if we have the function of, okay, this is ux times vy, then this is in the form of separable equation, because you can easily bring the vy to dy, mean dy over vy equal to ux dx. Then you can integrate both hand side. That will be the separable equation. Okay, however, if your fxy is not in the product form of ux and vy, okay, this is not separable equation, then we can try to study the homogeneity of a function fxy. So to study the homogeneity of a function of fy, okay, what you need to do, you just replace the x here by lambda x, y by lambda y, and if you can prove it is equal to lambda power n fxy, this is what we call homogeneous function of degree n. Okay, for example 1, show that fxy equal to x squared minus xy plus y squared is homogeneous function of degree 2. So what you need to do is actually replace the x by lambda x, y by lambda y, and if you can prove it is equal to lambda power n fxy, then this is the homogeneous of degree n. Once, okay, after substitute x by lambda x, so lambda x squared, so x by lambda x, y by lambda y, so lambda y squared, so this you have lambda squared x squared. So okay, so you notice each term we have a lambda squared, we factor out, so you have a x squared here minus xy plus y squared, and this one is actually the original function fxy. So this is what we have proved that from the function fxy, if we replace x by lambda x, y by lambda y, and we get it is actually equal to lambda squared fxy. So degree 2, this is what we call homogeneous function of degree 2. And actually, if a function is homogeneous, okay, the power for each term will be same for here power 2. Here we have power 1, total is power 2, power 2. So this is a homogeneous function of degree 2. Okay, example 2 shows that fxy equal to 2x power 4 minus x squared y squared plus 5 xy cubed is homogeneous function of degree 4. Shortcut is actually, I will observe the power for each term. This is x power 4, so this is 4. Here you have 2 and 2, add up is 4. So x power 1, y power 3, total is 4. So it should be homogeneous. It should be homogeneous. It should be a homogeneous function of degree 4. Or through the proper way to prove it is actually you replace the x here by lambda x, y by lambda y, and you simplify it. You can show that is equal to lambda power 4 fxy. Hence, this is actually homogeneous function of degree 4. I think you should be able to do it, right? This is only you replace the x here. Initially, this function fxy, you replace the x by lambda x. So this is make sure you bracket lambda x squared. So you expand it, you should have lambda squared x squared. Here lambda squared y squared. So total is lambda power 4. I mean each term we have lambda power 4, we factor out. So we have here, when you factor out, it's here x squared y squared. Here 5, lambda power 1, lambda power 3, so total lambda power 4. So x power 1, y power 3. Okay. And then what is homogeneous equation? The first order differential equation is called as homogeneous equation if it is homogeneous function of degree 0. Means, okay, first order differential equation, just now you have a dy dx equal to function of fxy. And if you can, and first of all, if you have like this form, dy dx equal to function of fxy, first step, check whether this fxy can be rewritten as a product of ux vy. If yes, then you use separable equation techniques. Otherwise, you will try to check whether this is a homogeneous equation or not. If homogeneous equation means when you replace your x here by lambda x, y by lambda y, you should be able to prove it is equal to lambda power 0 fxy. Okay, now example 3. Determine whether the following differential equations are homogeneous or not. Okay, to determine whether it's homogeneous or not means your right hand side is actually fxy. Then replace the x by lambda x, y by lambda y. Okay, and you can prove that it's actually equal to lambda power 0 fxy. Then this differential equation is homogeneous. Okay, because they actually cancel out. Normally, if a function is homogeneous equation, is always in the fraction form, mean the quotient form, and their power for each term are actually same. Yeah, y power 1, x power 1, y power 1, x power 1. So mean each term is power 1 and in the quotient form, so their power can be cancelled out. If you replace x by lambda x, y by lambda y, actually we have a factor of lambda, where the lambda you can cancel out, or which is actually lambda, mean it's actually 1 or lambda power 0. So this is what we call as, mean if when you replace the x by lambda x, y by lambda y, you can equal to lambda power 0 fxy. This differential equation is homogeneous. Okay, for B, without substitute x by lambda x, y by lambda y, because I can easily make a conclusion that this is not homogeneous equation, because here you have x power 1, y power 1, power 2, but this is constant, this is constant, so this is not homogeneous equation. Or through the proper way, you substitute x by lambda x, y by lambda y. So you have lambda x, x by lambda x, y by lambda y, and then you see that I cannot factor out, because here you don't have a lambda squared. That's why you cannot cancel out your lambda squared. That's why you cannot write it in the way of lambda power 0 fxy. That's why this is not homogeneous equations. Okay, so after you can determine whether a differential equation is not separable, then you can try to study whether it's homogeneous equation or not. If yes, then you can try to solve it using technique of homogeneous equation. So how to solve the homogeneous equation? First step, you use a substitution y equal to vx. Y equal to vx. Then y, where v is a function of x actually. V is a function of x. Then you differentiate both hand side respect to x. So you d dx of y, you have dy dx. So for the right hand side, you need to use your product rule, because v is a function of x, x of course is a function of x. Mean using the product rule of differentiation, your u is equal to v. Oh, never mind. No, v is actually the x, because normally we use when you want to differentiate a product form, you put ddx uv, right? uv. Differentiates a product form, you have the u v prime plus v u prime. So if u is v, then your u prime will be equal to v prime will be equal to 1. So you have uv prime, which is v times 1, v here, v u prime, which is x, v prime is our dv dx. So mean differentiate your vx using the product rule. So mean if you have proved that your first order differential equation is homogeneous equation, then you need to substitute the y equal to vx. Hence dy dx is v plus x dv dx. Okay, after simplification, the homogeneous equation will become separable equation in terms of x and v. Okay, you notice in after step 1, initially your differential equation is dy dx. Initially you have dy dx. Initially you have dy dx is a function of x and y. And then you have, okay, you can show that this function of x and y is actually a homogeneous equation, or is actually, okay, homogeneous function of degree n. Then you can use case y is vx. So substitute y equal to vx. Dy dx we substitute here. Y equal to vx. So means after this substitution, or after step 1, you no longer have the variable y, but you have v and x. Okay, and then you can simplify, okay, your works in step 1. You should be able to get a separable equation in terms of v and x. Okay, lastly, to get the solution, okay, because we want to solve dy dx, actually we want to get back the y, right? So you replace back, because from y equal to vx, okay, because in step 2 you have v and x. So and our intention is actually to solve the y. So replace back v is actually y over x. Only 3 steps. But okay, before that, okay, given dy dx equal to a function of x and y, if you can do it, you can separate function of x to dx, y to dy, then use separable equation. Otherwise, check whether, okay, they are a homogeneous equation or not. Mean homogeneous equation, you must prove that your f lambda x lambda y equal to lambda power 0 fxy. Then you can use the technique of homogeneous equation. Substitute y equal to vx, dy dx will equal to v plus x dv dx. Okay, after the substitution, you will have a separable equation in terms of v and x. To get the solution of y, replace back, because we don't want the v, we actually want the y. Replace back the v is actually from y equal to vx, then v will be y over x. Okay, let's look at, okay, 2 examples for the homogeneous equations. Okay, solve, okay, the dy dx equal to x squared minus xy plus y squared over xy. Okay, in shortcuts, I can confirm this is homogeneous equation because each term it has the same power, x squared power 2. Here x power 1, y power 1, total is power 2, y squared power 2, here power 2. So in the rational form, in the quotient form, then the power can be simplified. You can prove it is equal to, mean the fxy will equal to lambda power 0 fxy. Sorry, your f lambda x lambda y, mean this is shortcut quick way. Okay, I can make conclusion this is homogeneous equation. However, you still need to actually show, because this is from which one? Here. Oh, not the same. Never mind. And suppose, okay, before you solve it using homogeneous equation, okay, you have to quickly this one is actually what? Your fxy, fxy. First step, when you look at here, dy dx equal to fxy. Because you have the minus and plus, normally this is not separable because couldn't separate function of x to dx, y to dy. Then, okay, fxy equal to here. Okay, and then you just try, okay, to do f lambda x, mean x replaced by lambda x, y replaced by lambda y, and you should be able to prove that this one is lambda power 0, okay, f xy. for this example, okay, you can substitute x by lambda x. So mean this one you should have lambda squared x squared. Here x is lambda x, so lambda squared x squared. Okay, x is lambda x, y is lambda y, okay, and then plus y squared. So you will have lambda squared y squared. Okay, the denominator you have x is lambda x, y is lambda y. So you notice that each term you have the lambda squared, which can be cancelled out, become, from here, because the lambda squared can be cancelled out. Your lambda squared here, okay, lambda squared, lambda can be cancelled out. So you can prove is actually equal to lambda power 0 fxy. Okay, that's why I said shortcut. Okay, I just noticed if each term they has the same power. So if product form this x power 1, y power 1, total is 2, power 2, power 2, then it is homogeneous equation. Okay, if homogeneous equations, then you replace, remember, replace your y here, y by vx. Okay, you replace the y by vx. So y squared, you have v squared x squared. So x, okay, you don't touch the x, remain the same. Only y is v times x, so you have a vx squared. So y here replaced by vx. So vx times x, so vx squared. And dy dx will be v plus x dv dx. Okay, so this step. And then normally after that, this one, the v you bring to the other side here. So minus v. And you need to do some simplification. So minus v here, minus v. To do the simplification, you make here your denominator you have vx squared. So I need to multiply x squared. If I multiply, I have to divide by x squared. Okay. Then I can combine these two fractions as one quotient function. Okay, now we have the same denominator. Okay, vx squared. Minus v here, bring here minus v. How can I? Okay, before I simplify, sorry, I make a mistake here. This one I erase. Okay, from this step, you bring the v to here, minus v, and then, okay, before I combine it, actually I can simplify here first. Here you have a x squared, right? Simplify it, this become 1. This one, this is cancel. So when you cancel, then this is still 1. That's why I have 1 minus v, because 1, v times 1 is v. So 1 minus v plus v squared divided v minus v. Mean from here, you should get 1 minus v plus v squared over v, and then okay, minus v. So here minus v, then I use other colors. So to make the same denominator, to simplify, you have to make the same denominator. So I divide by v, I have to multiply back by v. Now I have the same denominator, right, over v. So over v. So 1 minus v. So you have 1 minus v. Okay, here plus this one, this term v squared. Okay, and the second term here, so you have minus v squared. So v squared minus v squared, that's why you just left 1 minus v over v. So for homogeneous equation, a bit tedious to simplify until you get the separable equation in term of x and v. Now it is become separable equation. I mean, after the simplification, you should always get a separable equation in term of v and x, because the whole thing here, this is function of v, this function of v. So you can bring all these things to here, and then the x times x over dx you bring to the other side. So v 1 minus v over v bring to left side become v over 1 minus v, x over dx it become dx over x, and then we integrate both hand side. So as what I said, given the first order differential equation, if you can separate the function of x to dx, y to dy, then you use the separable equation technique. Otherwise, you replace the fxy here, replace x by lambda x, y by lambda y, and if you can get it is equal to lambda power 0 fxy, this is what we call homogeneous equation. So to solve the homogeneous equation, it's very simple. You just replace y equal to vx, and then dy dx, and from y equal to vx, you differentiate both hand side and the right hand side using product rule. You should be able to get dy dx is v plus x dv dx using product rule. And then after some simplification, you will always get a separable equation in terms of v and x. Then you solve it using separable equation technique. But so later on is how is the technique of integrations. I mean the basic of a technique of integration. So the right hand side, I think integrate dx over x, you can easily get this is ln x plus c for separable. Remember, you just add up the integral constant at right hand side, and for the left side integral, integrate v over 1 minus v. You notice the quotient function, you have the same degree, v power 1, v power 1. So we here I factor out the negative, so my denominator become v minus 1, so v power 1, v power 1. And then you use the what we call the long division, because when you have the rational function, quotient function with the same power, you have to do the long divisions. Then mean the long division, I'll show you, v divided by v divided by your v minus 1. So v times 1, you will have v. Right? So you have, that's why 1, which one? V divided by v minus 1. So negative 1 times 1, you have minus 1. So you minus, this long division. V divided by v minus 1. So v times 1, you get v. So minus 1 times 1, you get minus 1. You have the minus here. So v minus v, no more. So negative 1, so you have 1. That's why you will get 1, means the result here 1. The remaining is 1. So positive 1 over v minus 1. Mean if your quotient function is the same power or the numerator degree is greater than your denominator, you have to do the long division before you can integrate it. After doing the long division, you will get this one, 1 plus 1 over v minus 1 dv. Then you can easily integrate 1 respect to dv, you will get v. Integrate 1 over v minus 1, you will get ln v minus 1. And then you just do the simplification. Mean I collect the long term together. Mean here you should have minus ln v minus 1 equal to ln x. So minus, I bring to the side with ln x, so I have a ln x plus ln v minus 1, okay, equal to ln v, okay, plus c collect to the minus v, so minus c. So for ln, if you plus, you can simplify it become 1 ln, and plus become multiplication. So ln x times v minus 1 equal to minus v minus c. To eliminate the ln, okay, remember ln is log base e, hence the x power v minus 1 is exponent this thing, exponent negative v minus c. Okay, and then exponent, okay, you can break it become exponent negative v multiply exponent negative c, where this is multiplier. Okay, when you have here minus c, so exponent negative v times exponent negative c. Okay, when you combine, it becomes exponent negative v minus c. Exponent negative c is constant. Let's replace it as a. Okay, and lastly, v you replace by y over x. Okay, you may leave here, or you want to simplify some more, also can, or you expand in. So x here cancel. So you have y minus x equal to a exponent negative y over x. Okay, this is the first example. Let's look at one more example. Okay, the previous example, you have the nice form dy dx is function of fxy. However, this one you in the differential form. Okay, so to do it in the form of dy dx, mean, okay, each term here I divide by dx. So this one I divide by dx. So 0 divided by dx, of course you get 0. Okay, so this one you cancel. So you have here x squared dy dx equal to, okay, this one bring to right side, it become, okay, negative bracket y squared minus xy dx. Sorry, here the same x squared, if you do it, if you divide dx, first step here, so now you have x squared dy dx, or in the notes here actually we didn't divide, I just bring this term, the dx term, to right hand side first, and then later on I divide each term by dx. So I have dy dx here. Later on I divide by dx. So this one divide by dx. So I cancel. So x squared here is multiply, bring to the other side, become divide. So I have negative y squared minus xy. If you put negative here, it's same as you have like this form. Okay, and if you check, this is actually homogeneous equation, because shortcut you see if they are in the quotient function and the power for each term are same. Here y power 2, x power 1, y power 1, okay, x squared, so it's power 2, then it is a homogeneous equation. Or, okay, you can go to prove this is a function of xy, this function of xy, then you prove that f lambda x lambda y must be equal to lambda power 0 fxy. Then this is what we call homogeneous equation. Okay, for homogeneous equation, replace the y here by vx. So y squared will v squared x squared. So y is vx times x of vx squared. So x squared. Okay, and then dy dx is v plus x dv dx. You cancel the the same power x term first. So you have here, so minus v squared, okay, negative and negative, so you have positive v minus v squared. Okay, this one is same with this line. Lastly, the v at the left side you bring to the other side, so we have, okay, or v left side right side you cancel. So left x dv dx equal to minus v squared. Then now after simplification you get a separable equation in terms of v and x. Okay, so you bring the v squared to left side, x over dx to right side will become dx over x. So left side become dv over v squared. Negative, normally we leave it at right hand side. Then you integrate both hand side. Okay, so integrate 1 over v squared is actually equal to integrate v minus negative 2 dv. For integration, remember, okay, you have your power will be increased by 1, so you have v power negative 2 plus 1, you have negative 1, so you divide by negative 1. That's why you get negative 1 over v. Integrate 1 over x ln x, because negative and negative cancel. Sorry, so I have negative. Okay, because integrate 1 over v squared, we get negative 1 over v. Integrate negative dx over x, here you should have negative ln x plus c. Okay, then from here, ln x, negative ln x, we bring to left side, so you get positive ln x. So c minus 1 over v, we bring to right hand side, become plus 1 over v. So to eliminate the ln, so ln is log base e, so x will be exponent power c plus 1 over v, where again you can break the exponential term as exponent c multiply exponent 1 over v, where exponent c is actually your a, okay, a constant a. So x is equal to a exponent 1 over v. Lastly, you replace v is actually, v here is y over x. So you have 1 over 1 over y over x, or become x over y. Okay, if this case, I repeat again, for the homogeneous equation, okay, they either give you in the nice form dy dx is a function of fxy, and if you notice the function of fxy, you cannot break separate function of x to dx, y to dy. Then what you need to do, you replace the x by lambda x, y by lambda y, and if you can prove that is equal to lambda power 0 fxy, this is a homogeneous equation. Then the solution for homogeneous equation, only 3 steps, but it's a bit tedious in simplification. You just need to do y equal to vx. Substitute y equal to vx, x maintain, and then differentiate the ddx both hand side to get the dy dx, which is v plus x dv dx. So mean substitute y is vx, dy dx will v plus x dv dx. Okay, after some algebraic tedious simplification, you will always get a separable equation in terms of v and x. Then you solve it using a separable equation technique, but now is v and x. Lastly, replace back your v is y, v is what? Y over x, because you want to solve for y. Okay, you may have a differential form like this, then you have to simplify so that you can get dy dx is a function of fxy, and okay, again, if you can collect the function of x to dx, y to dx, and y to dy, then you solve it using separable equation technique. Otherwise, check, okay, by substitute x equal to lambda x, y equal to lambda y, check whether you can get it is the f lambda x lambda y is equal to lambda power 0 fxy, or shortcut actually, if you have the quotient function like this, the power for each term must be same. That's why they can cancel out their lambda. Okay, cancel out lambda, or lambda power 0 is actually you have 1. Okay, then again replace the y by vx. dy dx is v plus x dv dx. After some tedious algebraic simplification, you should be able to get a separable equation in terms of v and x. Then solve it using separable equation techniques. And then lastly, replace back the v is y over x. Okay, with this, thank you for your attention.